Love this problem, but I never can draw the airplane quite right. An airplane is flying on a flight path that will take it directly over a radar tracking station. We're assuming horizontal flight. If c, the diagonal distance from the plane to the radar, is decreasing at a rate of 300 miles per hour when c equals 13 miles, what is the speed of the plane? The altitude of the plane is 5 miles and does not change as the plane flies. What? Okay. Most of the time on these you'll be given a picture. In this case, I'm going to draw it. So here's the ground. Here's the plane. Oh boy, here we go. This is going to be embarrassing. I'm going to just stop there before I start adding like the tail to the plane. Maybe it's not a functional plane and the wings aren't symmetric, but whatever. And there's a little radar tracking station down here. We'll put a little 1988 satellite dish on it. There we go. And there is a distance we will call c. That is the diagonal distance from the plane to the radar. We're going to call that c. And it is decreasing at a rate. Okay, we're about to start listing what we know, but what we know so far, the 300, is not c, it is the rate of c, and it is decreasing. So we have not yet read what c is. There it is. But we do know that c is decreasing at a rate of 300 miles per hour. And it makes sense that it's decreasing because the plane is flying this way. Tongue got tied. Okay, c is 13 miles. What is the speed of the plane? Speed of the plane, well, when we measure speed, we measure it horizontally. So let's continue with what I believe is a fairly obvious right triangle. Okay, I'm going to call this C. Let's go Pythagorean on this. Let's just go for the obvious. We'll say this is A, and we'll call this B. And I think you can assign this to be B and that to be A, but personal opinion, A is altitude, B is base. That's just the way I do it, so we'll go with that. They are actually asking for the speed of the plane, which will be that right there. Okay? That is the rate, the horizontal rate of the plane. So it's flying this way, that is the speed of the plane. The altitude of the plane is 5 miles and does not change as the plane flies. So dA over dt, all right, this is subtle, but it's in there. The altitude does not change. What is the rate of change of something that does not change? 0. The altitude does not change. Okay, so we're clearly missing what they're asking, obviously, but we're also needing to find B. We don't know what it is, so we'll switch colors. I'm going to come over here and I'm going to write a squared plus b squared equals c squared. And let's start figuring it out. Well, first of all, I like to jump straight into the calculus. And that's just what I do. So we're going to take the derivative of the entire thing. We'll take the derivative of this side with respect to time, and the derivative of this side, didn't leave myself much room again, so d dt with respect to time. On the right side, the derivative of c squared would be 2c, and then dc dt. The derivative of this side would be 2a dA dt plus 2b dB dt. And we'll just start plugging stuff in. And at this point, you can realize that there's something you don't know, but you already knew that from the picture, right? So, one more random thought that I think is really cool. You could get rid of these 2's. They're not going to help you out very much. So if you divide everything by 2, you'll have A dA dt plus B dB dt equals C dC dt. We'll go from there. All right, A is 5, dA dt is 0. B, don't know. Let's find it. Let's just stop right here and find it. A squared plus B squared equals C squared. A is 5. B, we don't know. C is 13. So sometimes you have to pause your calculus to do your algebra, right? So I'll go ahead and save you the trouble. This is a very common right triangle. 5, 12, 13. Trust me, it works. 12. So we now know that B is 12 miles, actually. Horizontal distance the plane is 12 miles from the radar tracking station. So B is 12. dB dt is that thing we don't know. I don't know why I put it in parentheses, but that's okay. C is 13, and dC dt is negative 300. Now, in a minute, we're going to have conversations about the sign of these things and the sign of the answer. 5 times 0, that's just gone. And so dB dt is equal to 13 times 300, negative 300, and then divide by 12. So let's do that. Let's do that very quickly. 13 times 300, negative, divided by 12. So negative 325 miles per hour. Now that is fantastic, but let's just read it carefully. What is the speed of the plane? You'll never say speed is negative. You can say velocity is negative because that implies direction, but speed is never negative. So I'm going to just say the speed is 325. The speed of the plane is 325 miles per